So this example is going to be very similar to the last example, only now we're looking at an algebraic expression of x rather than a number. So again, we're going to set our u equal to what's inside the parentheses, which is arc cosine of x. So therefore, we're trying to find cotangent of u. So what I can do is I can undo this by taking the cosine of each side. So the cosine of u is going to be equal to x. So remember that cosine is also equal to adjacent over hypotenuse for a triangle. So if we make a triangle here, uh, my adjacent side is going to be x, and my hypotenuse, since cosine of u is technically x over 1, we can make that 1. Now the only thing we don't know that's not in terms of x is the opposite side. Using the Pythagorean theorem, x squared plus the opposite side squared equals 1 squared. So if we solve for the opposite side, we get opposite squared equals 1 minus x squared. I just subtracted the x squared from both sides. And then the opposite side becomes the square root of 1 minus x squared. So therefore, my cosine is, I'm sorry, my cotangent, remember cotangent of u is equal to the 1 over tangent of u, which would essentially be, instead of sine over cosine, cosine of u over sine of u. So we know that cosine of u is equal to x. We already determined that. And then on the bottom, we have the sine of u, and sine is going to be our opposite over hypotenuse. So that would be square root of 1 minus x squared over 1, essentially. So that's kind of our final answer. We just need to rationalize it. So cotangent of u would be x times the square root of 1 minus x squared over 1 minus x squared. So see if you can put that in practice for yourself and determine what the cosine of arctangent of x would be.